Okay, today we're going to I want to start now so that at least we cover almost everything in 1 hour. I know the other ones will be late. So today we're going to be looking at Boolean algebra. We're going to start with Boolean algebra. Then after Boolean algebra, I think we'll have the whole course content. So Boolean algebra. So Boolean algebra is another way to basically simplify a circuit. So Boolean algebra has got laws. We have laws like identity law, idempotent. Yeah, how to spell that? Idempotent law. Identity idempotent. Obviously, the distributive law. Distributive. Annulment law. Annulment law. Right. So before we go any further, there's exam notes 1, which is loaded on my Unisa. Please, you need to exam notes 1. You need to go through this document. It's called exam notes 1. Where is that? So this exam notes 1 will have all of these rules of Boolean algebra here, right? So you don't really need to know. You don't really need to know. No. You need to know all of them. Let me just say you need to know all of them, but you need to know the application, how to use them, right? So I'm going to explain this one, where it comes from. Sometimes they might ask you, you might need to simplify, let's say a case whereby you have a plus 0, right? Then you need to know that it's supposed to be a. We're gonna work through those examples. Sometimes it will be a plus 1, then you need to know it's 1. A and 0, you need to know. Sometimes they will ask you, name this law, right? So that's what I'm gonna show you. So those videos are already on YouTube. So we're gonna look at these laws, right? Then I'm going to just play. It's 2 minutes videos. Don't stress about it. 2 minutes videos. Yeah, okay. So this law that we're gonna look at here is called the identity law, right? The identity rule. So if you can see already from the screen, I am already saying a plus 0 is a, and a and 1 is a, right? So, but let's hear.
So we can't hear the video.
All right, right, no, not a problem. Let me do this. Okay, so let's start with the identity law. So the identity rule says a plus, where is it again? A plus 0, okay? A plus 0 is a, and a and 1. A plus 0 is equals to a, right? And then a and 1 is equals to a. Okay, so where does this rule come from? So let's use an OR gate, right? Let's use a 2-input OR gate. So what we're trying to say here is that any value this is input A and input 2. Any value between the two inputs that is odd with a 0, the output will be that value, right? So we know in an OR gate, if you pass a 1 here and a 0, the output will be 1, right? So in an OR gate, anything, like anything odd with a 0, it will be that thing, right? So this is what it's saying here, identity law. So what is the identity law saying? What does it mean? It means this input and the output will be identical. Okay, let me make another example here. So if we have this, okay, let's say here we have A plus B, right? A plus B. Let's say it's also in bracket, this A plus B. Then here we have 0. It means our output will be A plus B. So my point is, it doesn't matter. It doesn't matter what this value is. As long as any value is odd with a 0, the output will be that value that is odd with a 0. Right? Are you guys with me? Okay, so please,
Yes,
if you
I'm
have,
with you.
all right, if you have any questions, because I can't see if you picking up your hands, just distract me. It's not a problem, I don't mind. Okay, and then the next example is this one with an AND gate. So remember, in an AND gate, if we have a 1 and a 1, the output is a 1, right? Then if you have, for example, let me do it like this so that it's easy for you guys to relate. 0 and a 1, the output will be a 0. Did you guys see, notice something? So here, this value, if it's a 1, the output will be this value, which is a 1. If it's a 0, the output will be this value, which is a 0. So we're just saying, if the input is ended with a 1, the output will be that input that is ended with a 1. Right? So this and this will be identical, right? And this will be identical. Okay, so now let's go to our 12 laws. I summarized everything into 12 laws and then see where is the identity law. Is the exam notes one? Okay. So this A or 0, what law is this? Identity law, right? A, where is it? A plus 0 is A. This is an identity law, which is law number 1, okay? And then A and 1, right? It's A. This as well is the identity law. We just proved it now, right? So this is the identity law. The one of the input odd with a 0 will be the input, right? Then here, one of the input ended with a 1 will be that value of the input. That's all that it says, the identity law. Okay. So let's move on to the next one. Guys, these laws, I don't cram them out of my head. I only cram them when it's exam time. Leripiercus, idempotent. The next law will be the idempotent law. You know, we have annulment. Okay, let's look at annulment law first. Okay, so annulment law says A odd with a 1 is equals to 1. A ended with a 0 is equals to 0. So it says in an OR gate, but I'm going to draw it for you now. A plus 1, A or 1 is equals to 1. Let's draw it. So we have the identity law. The next one is the annulment law. So here we're saying A odd with a 1 is equals to 1. Then A ended with what did I say? A ended with a 0 is equals to 0. Okay. A ended with a 0 is equals to 0. Okay. Where is it coming from? Annulment, it means null and void, because it comes from the history, it comes from marriage, basically marriages that do not exist, right? So what it basically says is that this value doesn't exist, this thing doesn't exist, and this thing doesn't exist, for simplicity, right? So if you wanna describe it, you can say anything that is odd with a 1, right? Any input odd with a 1 becomes a 1. Understand? And any input ended with a 0 becomes a 0. So if they say, please describe it, you can say that. But this is the OR gate. Let's start with an OR gate just to show you where it's coming from. So my point is, if we put a 1 here and a 1 here, in an OR gate, we know 1 and 1, it's a 1. If both inputs are high, it will be a 1. And if any of the inputs are high, it will be a 1. So 0 and 1 in an OR gate, it will be a 1, right? So this 0, substitute this variable a here. So even if we do this, even if we say a and 1, a odd with a 1 will be a 1, right? This a, it's a variable, guys, right? It's a placeholder. So it means this a can be 0, right? If it's 0, the answer is gonna be 1 here. This a can also be 1. This a can be 1. If this a is 1, the answer is still gonna be 1. Do you guys get my point? So any value here, this is a, any value odd with a 1, the output will be 1. That's what the annulment law says. Okay, and then if we're gonna use the AND gate, we know that AND gate, both inputs must be high in an AND gate for the output to be high. So an AND gate works like this, right? 1, 1, it should be 1, right? And then if, for example, one input is low, and if one of the input is low, the output will always be low. So now this is what the annulment law is telling us. The annulment law is saying if one of this input is low, the output will be low, right? So it doesn't matter what the value of A is. If A is 1, the output, and this value is still 0, the output will be 0. And then if A is 0, next years, if it's 0, then the output will still be 0, right? So it doesn't matter here what this value is. So this value, we consider it as null and void. So it's what? This is the annulment law coming from marriages that do not exist. So this is like maybe a side chick that doesn't exist, right? This is the wife. This is more important. This is more important. So this doesn't matter, and this doesn't matter. Doesn't matter, it doesn't matter. Only this matters, right? 1, 1, 0, 0. Okay, that's the annulment law. Then the third one, quickly, idempotent law. Idempotent law. Let me just see how do I describe the idempotent law. Idempotent.
Sir?
Yes.
I was just wondering about that amendment law. I watched a video where they call it the dominance law. Is it important to know the names?
Uh, yes. It's not really. It's only 1 mark. But I would also want to know the name, especially for those guys who really like getting 100%.
Okay.
There has been, an exam where you were asked the name of the law. I know it's not in any of your textbooks, and I know even in my notes I don't have the names. That's why I just put them on YouTube. I don't have the name of the
Okay, so I
specific.
should rather just forget about the dominance law and rather call it the annulment law.
Yes, please,
Oh,
yes. All right, thank you. That's a very good question. Okay, and then I the content law. Let's see if we have the ID content law. Let's see, I think I'll get it from here. Identity law, we're there. Here's the ID content law. So A plus A is A and A is A, but this one is simple, okay? Okay, but let's go back to, sorry guys, let's go back to my 12 laws first. Right. So now we said A and A, this is identity. It doesn't matter this. Then we said number 4 as well, A and 1. This is identity. One of the input will be identical if it's ended with a 1. And here, if it's odd with a 0, it will be identical. So that's why it's the identity law. Now we just looked at annulment law. Annulment law was this one, right? It doesn't matter this value of A plus 1. We take this, as long as it's odd with a 1, the output is going to be the value of this input, right? Then as well, if it's odd with a 0, the output is going to be the value of one of these inputs, A and 0, right? So the output will be 0. It will be one of these input. So we know identity law. Okay, so I will update this thing now. This PDF. Identity law, annulment law, identity law. So now we go into idempotent law. I think it's gonna be this one and this one. Let me just look for the last time. A plus A is A and A, A and A is A, obviously. Okay. So idempotent law, which is the last law, idempotent law. Okay. So idempotent law says to us A or A is equals to A. Then it tells us as well A and A is equals to A. So we can say if the same, if maybe we wanna, they say explain it, right? You can say if one of these inputs, if the inputs are identical, right? The output will be identical to one of the inputs, right? Even here, if the inputs are identical, the output will be identical to one of the inputs. So this is how we can prove it. So in an OR gate, if you have a 1 and a 1, your output will be 1, right? In an OR gate. If you have a 0 and a 0, the output will be 0. Get me? So it doesn't matter. It doesn't matter what this is. I think I'll go further by explaining in the what is it on YouTube, that if maybe you get, I know there are examples whereby you're gonna get BC plus BC plus, let me do something like this, A and A, right? So now you should know BC plus BC. Sometimes when you solve Boolean algebra problems, you're gonna get BC plus something like this, and then they're gonna say simplify. Then you need to write the name of the law that you used. Or that's why it's important to know the names. Yes, that's why it's important. So now you're gonna say BC plus BC, then you're just gonna simplify it to BC, right? BC plus A and A, then you're gonna say annulment law. In the past, I know people are saying law 1, law 2, law 3, law 4, but it got confusing because we didn't know what is law 1 and law 2, right? It's not like a standard thing. Okay, then from there, you're gonna come again and say BC plus A annulment law, Okay, yeah, so you will definitely get a question like this that wants this in your exam. It's always in your exam, always. Okay, so I did the example of the OR gate. Let me jump to the end. This is the last law actually. After this distributive, but it's very straightforward, that one. So if you have an AND gate here, then your input are identical, this will be 1, right? If both inputs are high, the output will be high. Then if both inputs are low in an AND gate, the output will be low. So this is all that this law is saying to us. If the inputs are identical, the output will be the same as one of the inputs. That's it. So let's check from our 12 laws. What does it say? Okay, so we have this one, identity law, A plus 1. What is this stupid one again? Annulment law. Okay, this one, annulment law. This one, identity law. A plus A. This will be our new law, which is the idempotent. Yes, idempotent law, right? And then this one, A and A will be the idempotent law. Okay, so I don't know this one. What is this one? A plus, I can prove it, but I don't know what can we call this one, but we'll see now. Okay, this one, okay, I need to describe this one. Okay, this one we can prove it. Yes, here's the one that I want you guys to know as well. Distributive law. This is the distributive law, right? Distributive law is everything that if you need to multiply out of a bracket, basically, like in mathematics, two open bracket x plus y, that multiplying out, you are distributing, right? You taking this, you making it be bigger. So we call it distributive law, right? Distributive law. Let me just write it down here. Then I need to distributive law, distributive law, right? So distributive law, like if you have 2x plus y, so this multiplying out of 2x plus 2y is, you are basically using distributive law. Distributive law, right? Okay. Now, there's something that I want to touch as well. So check here, we have how many laws? We have 1, 2, 3, 4, right? Then
So,
this, yes, hello?
which laws, how to know which law is what with the laws you showed us just now? Or is there in the notes where I can see which law is what?
It's in, hence I wanted to open this. It is in this recording, but please just go look for this identity laws. It's only 2 minutes, guys. It's only 2 minutes. Go look. There's idependent law, there's identity law, there's what's the other one? Annulment law, right? So if you can have those 3 laws, you are already sorted, right? And then again on this document, you have this exam notes 1, right? If I were you right now, you see A plus, this one is the identity law. I would write identity law here, right? Identity law. So identity law is if one of this, if an input here is odd with a 0, the output will be what will be that input. You see, this and this are identical, right? Identity law. Even law number 4 is identity law. If an input is ended with a 1, it will be one. The output will be that input. So you get. So here I would write, if you have. Okay, you can write it down now. Just write number 1. We know it's identity law. Number 2, it's annulment law. Number 3, annulment law. Number 4, identity law. Number 5, it's idependent law, idependent. Then number 7, it's idependent law, right? Number 5 and number 7. I'm still thinking how to prove this one, number 6 and 8. So idependent law, number 5 and number 7. Are you with me?
Yes, I am.
Okay. Then we are going to...
I'm sorry. Please repeat 7. What was 7?
7 is idependent.
Thank you.
Idependent law. Okay. You're welcome. Yes. Okay, this is what I was saying. And then remember distributive law, I just said now, distributive law, anything that you think is mathematics. If you need to break down a bracket or maybe, let's go backwards here. So 2x and 2y, maybe you all of a sudden trying to find the common factor, which is 2, right? Then you will never go this deep though. X plus y, all of these things, just name them distributive law. Your lecture will make it right? Distributive law. The moment you need to break something down, just name it distributive law, right? So we're gonna go through an example. I just want, every time I touch this subject, I go to Bolean algebra, right? So, but the way, not Bolean algebra, sorry, Demorgan's theorem. This is Demorgan's theorem. Guys, Demorgan's theorem. They will ask you theoretically, they will say state both Demorgan's theorems. Right? This is theory. This is normally 4 marks. 4 marks, right? If you guys just go, you don't need a textbook for this thing. Just go to Google, then state both Demorgan's theorem, write 4 lines in your notebook, right? Cram those 4 lines. Then if ever they ask it in a theoretical form, then you know what you need to do. Because I don't know how to explain it in a theoretical form. But anyway, it's there in Google. Please just get it, write it in your notebook in case they ask this. They have asked this in the past 4 years, I think once or twice, right? In this way, theoretically for 4 marks. But this is Demorgan's theorem. This is what we did in Demorgan's theorem, grade 10, yes. Demorgan's theorem is grade 10. A plus B, right? So Demorgan's theorem says if A or B, okay, now let me put our thingy. So now Demorgan's theorem says if you need to divide these two things, you need to break the line and change the sign. So you break the line, change the sign, right? Break the line, change the sign. Let me see how I said it here. You should have some Demorgan's theorem. Yes, break the line, change the sign. Okay, I'll explain it like this. It's actually easier like this. So if you have x, y, odd, not odd, in inverted, right? So if we have, yeah, but it's still, yeah, still the same anyway. So now if you have this and you want to split them, this will be, let me put it here, sorry guys, AB. This will be A, right? Break the line, you break the line into two, AB, then you change this side. This was an OR gate, now it's an AND. The line has been broken into two, right? Check, let me repeat myself. So you break this sign. This complement was over A or B, this complement, right? So you break this complement individually to suit this variable and to suit this variable. But the moment you do that, you need to change the sign. Right? This can be proved. I can prove this with the truth table. The output will be the same. That's what Demorgan's theorem is. Demorgan, I don't know if it's a person or what, but this person built this gate. This gate, for example, this is, let's talk about something like a two-door car. Door one, door two, passenger and driver door. All together, complemented, switch off the light. You know, this cars of nowadays, if the doors are open, the lights will be on, right? Yes. So he's saying that even if you buy an inverter and not A, if you get a not A, right, and that with a not B, you will still get the same output as this thing. Do you get my point? So if you are, why do we go in this level? If you check, if you were an engineer, here you are going to use 1, 2, 3 gates, right? Here you can just use 2 gates. 3 gates, let's say each gate costs 10 rands, 30 rands, but your design can just use one inverter. You will feed it twice anyway, but I know it's not important now, but my point is it saves money. It's a way of simplifying. That's why Demorgan came up with this thing, is to simplify, right? So it's this case, and then the second case will be A plus B. Sorry guys, let me just switch off here. Okay, the second case is going to be the end. So it's gonna be, let me just put this phone on silence. I'm so sorry. Okay, sorted. So it's going to be A and B. Okay, let's not put A and B. Let's use what's in those notes. XY complemented. XY complement. So you know in between it means it's multiplication or it's an and, right? So here you can break the line. Break the line. Y. Break the line. but you change the sign. Right? So this is what Demorgan's theorem says. Hence, I say there are two. So here, there are two. Just go to Google and get the theoretical meaning. If I get it, there is one student who has said it. I asked in one of the chats, if I get that explanation, I'll post it, but just go, maybe just read. It's only 4 marks, but you need to know this one and you need to know this one. It is always in your exams, guys. It is always in your exams. Okay, I'm gonna show you how do they ask in your exams. So again, another law is if you have A, this normally goes with your Demorgan's theorem because I'll show you how now. If you have double complement, right? Remember A complement, A complement, if this was a 1, it really means 0, right? You get me? So if this was high, if the light was on in your room, then we invert it, right? We complement it. We invert it, we invert it, we get the opposite out of it, right? So it's gonna be 0, it's gonna be off. But if we need to invert it again, get the opposite of off, it's going to be on. You get me? So this is the same thing. They are saying A, that input, if it's complemented twice, it's just A. Do you get me? If it's complemented twice, it's just A. Okay. So let's see the applications of these things. The applications, let's go back to exam note 1. Exam note 1. Great stuff. So we're going to do this one. Can I take a picture so that my phone is full? Can't I copy this? Or maybe let's do Boolean algebra first so that we can fix this rule 10. They used to do that, but now once they got mixed up, they stopped doing that. You see, is that rule of ours again. A plus B. Let's start with this one. So now here we need to prove A plus AB is equals to A. Let's try that one first. A plus AB is equals to A. So let's prove it. A plus AB is equals to A. Say we need to prove that. Okay, we can see here already A is a common factor, right? There's A here and there's A here, right? With B. Okay, so what we're gonna do, we're gonna say A 1 plus B is equals to, right? A 1 plus B, right? So this is that distributive. Remember, now we got the common factor. So now they're going to say we must put, what law did we use? Distributive, right? What did we do? A was here and A was here. We took out A, then we know it's 1 here, right? And then we took out A, then we know it's B here. So A multiplied by 1 will give us A multiplied by B will give us AB, right? Great stuff. Let's go back to our, so now before you write, just write this. I don't know, I don't know how are your exams, but in the past, what I would encourage the students to do is that when they write in the question paper, they must first start writing all these laws, right? There are 12. Just write them down and then start their question paper, question 1, question 2, question 3. Then when they get to Boolean algebra, then they know that they will verify with this, right? They will verify with this. Okay, so you need to study them, memorize, study, and then put them, write them down. But if you really understand gates, you don't really need to write all of these things down. Okay, so let's see. So we have 1 plus we have 1 plus b. Let's say 1 plus a. Now let's go 1 plus a. So 1 plus a, let's do it out of our heads. So 1 plus b, I mean a, and 1 plus b is equals to 1 plus b is equals to b. Is the identity law. 1 plus b is equals to b is the identity law. Let's check. Now you'll understand why I say please write it on the side. 1 plus, okay, 1 plus b, sorry, is equals to 1. 1 plus, oh yeah, here it is. 1 plus a is equals to 1. This is the annulment law, okay? Let's see how can you verify here. Okay, here they used b, it's fine. So they say if they are saying if b, right, and then 1 in an OR gate, right? Remember this b can be 0 or 1. If it's 0, the output will be 1, right? If it's 1, the output will be 1, right? So I know just from drawing this gate, I know, okay, let me put this as 0 so that you get me. So 1 plus b, if we need to say, check what is 1 plus b, we can say, let's give b 0. We're going to start with 0, then we're going to give it 1. Okay, this will always be 1. 1 is here. If it's 0 here, the output will be 1 in an OR gate, right? Then we remove the 0. Okay, then we remove the 0. Let's just scratch it out like this, and then we put a 1. 1, 1, it will be a 1. So you see, it means 1 plus b is a 1. Right? Are you guys with me? 1 plus b is a 1. So it is that, what did we call this one? We called it the annulment law. So we said marriages that do not exist, this does not exist. As long as one of the input is a 1, we don't care what this value is, right? We don't care what this value is. The output will always be a 1. So now you need to, is there an eraser here? Okay, now after doing this, when you put it here, you need to put the name of the law, Control Z. The name of the law is annulment law. Annulment law, right? This one. So now this, remember this is 1, right? So now we're not done yet. This is A and 1. So now you are me, you didn't study for the exam. You didn't study, you don't know what's the name of this law. So what do? This is an AND gate. You go back, say, okay, it's fine. I'm going to draw this thing. I'm going to draw the AND gate. Yeah, sorry, guys. Let's just pretend it's an AND gate. Okay, then I'm going to put 1 here. Then I'm going to put a 0. 0, 1, the output will be 0. You see, it's like this one is going to take this, right? Then if it's 1 and 1, the output will be, if it's 1 and 1, the output will be 1. So it means there's an identity law. It means the value of this A is everything, right? So this will be this value A, it will be the output. If A is 0, the output will be 0. If A is 1, the output will be 1. So what law is that? Is the identity law, right? One of the input ended with a 1. will be that the output will be will be that input. So this we call the identity law, right? Okay, let's check A and 1 quickly. PDF A and 1, yes, we said rule number 4, that's identity law. A and 0, identity law as well. A plus 1, this one annulment. A and 0, annulment as well. Then idempotent, which is 5 and 7. Then this is the 2 bars, which becomes a 1. Then we said everything else, if you're dealing with these things, we know it's distributive. Okay, if you're factorizing, here it is, distributive law, then they put, so we no longer use this, rule 2 and rule 4, right? Unless if you can write them down maybe on the side and then write these rules and then say is this rule, but please, just to make it simple for yourself, just write the name of the law. Okay, so we've done this one. Let's see what else is there. Okay, another interesting one is this one. Okay, let's see here just to save time. Okay, so here we had A plus AB. What did they do here? A plus AB. Okay, now let's leave this one. Not A, not B. Okay, so they took it from this one. And they took it from this one. A, they took it from this one. So now, this is what we just proved, right? A plus AB by taking out this. We know that it's A, is the first thing that we did. We know that it's A, they just worked reverse order, right? Reverse order. Okay, let's leave that one. But it's basically what we just did there. Let's leave that one. It's not a good example. Yeah, which one is a good example? So we need to do this two. We need to do this one, and we need to do this one, right? This one quickly. So if we do this one, okay, let's see what they did here. So here, A plus B, A plus C, you know from grade 10 when we multiply out the brackets, we take this one, this A and this A. So that's why you have AA here. Then you take this middle ones, you multiply them together. So here it was A and C, then A and B, and then BC, BC. We call it distributive law, right? Distributive law. We multiplied out the brackets. Then we know A and A, it's A, right? A and A, it's A according to our laws. No, they are here. A and A, it's A according to our laws. Then we called this law, what was this one? Idempotent law, right? Idempotent law. A and A, it's A. We proved it as well. So that's the idempotent law, right? That's why we just have an A here. Then we have AC, take it down like that, AB, take it down like that, BC. Yeah, rule 7, which is idempotent law, right? Then here, A plus AC, we took out the common factor, is the same as the first example that we did. We took out A, then we said 1 plus C, right? So if we multiply this out, A and 1 is going to give us A and C is going to give us AC, right? So this is, remember I said when you deal with multiplying in and out, distributive law. So distributive law is very simple. As long as you multiply in and out, you will know. Okay, then this remains the same and this remains the same. Then here, now, remember we have this 1 plus C. We proved that, what is this one? This is the idempotent law. What is the annulment law? This one is law number 2. It's this one, A plus 1, which is 1, right? Barrested. Okay, here it is. 1 plus C, which is 1. I even drew it not so long ago, right? So it's annulment law. So this 1 plus C, it equates to a 1, right? That's why you see A ended with a 1 with this now. Then this and this remain the same. So this is the annulment law. Okay. Then we go down. So now when we go down, A and 1. Okay, I'm gonna try 2 ways. A and 1, we know it's A. Was that the identity law or what? A and 1, A and 1. A and 1, it's a yes, it was the identity law. Law number 4. A and 1. A and 1, yes, it's A, identity law. Then we have A, B, then BC. So we have A, B, and BC. So this BC, you see, we left it here. Then what we did here is that we took A. This is just A, guys. Leave this one. It's just A, because it's the identity law. A, then we took we took out the common factor, which is A. Then this was 1 plus B, right? Right. So we have A, 1 plus B. So we know, yeah, this is distributive law. Then we know 1 plus B still it's just a 1, right? 1 plus B, it's a 1. It's like this law is very important. 1 plus B, it's this one again, annulment law. So the annulment law is very important. It doesn't matter what this is. As long as it's odd with a 1, it will be that. Okay. 1 plus B, it will be a 1. And then A and 1, it will be the identity law again, right? A and 1, it will just be A from the identity law. Okay. Then we're done here. This was a 1, A and 1, identity law A. This BC comes as it is. It comes as it is. So the most important laws here were annulment law and identity law and distributive law, right? To prove this Bolean algebra. So guys, please, all the Bolean algebra tricks or difficult questions are here. Practice this. Okay, so now let's go to my favorite. Okay, so this is my favorite. I like this one. So, this is A plus BC. So we need to break the line and change the sign. Okay, A plus BC. Let me write out this one. A plus B, A plus BC, A plus BC plus DEF. Plus DEF, okay? Come on, plus D, E, F, okay. Let's see on tab. Then we know it's A plus BC naught, A plus BC naught, BC naught. Yeah, A plus BC naught, plus BC naught, everything complemented. Then we complement that. I think you will understand it better if we do this one like this. Then D, E and F in its own bracket, and F naught. E and F, I think it's a plus here. In its own bracket and complemented. E, yeah, F naught. Then D does multiplication, complemented, then one big complement. Yeah, this is multiplication. Then we complement this, and then we have one big complement. Okay, so now how do we go about here? So we're gonna break this line. This is one variable, right? This is one input, and this is another input. So we're gonna break the biggest one first, right? Which is this one. So what are we gonna do? Break the line, change the sign. Break the line, change the sign, something like that. So we're going to break this line and change this middle sign. So how do we do that? So we go here, break the line, and then we come here, we break the line, right? This top one. Then we just change the sign. Let's just put a dot here. Good. Then we write everything as it is. Here we had this, and then we had that, and then we had A plus B, C naught. A plus B, C naught. Okay. Then we had the sign has already changed here. We have this one, which is this one, which covers the D, right? It covers the D as well. Then we have this one, which covers only E and F. This one which covers E and F. Then we can have our D, open bracket, E, just make space, it's fine. E plus F. I think this F is not, hey? There should be a not on that F. Yeah, there's a not on the F. Okay, so let's complement the F. So it was supposed to be complemented. Okay, so now we broke the line, change the sign. So now this is already 2 marks, right? So now we go to the next one. Remember I said, what did I say? Wacht net 'n bietjie. Yeah, this is this one. Let's make it this. Remember I said A.
Sir,
Uh-huh.
isn't there supposed to be 3 complements on D, E plus F? You have 4 now.
For 1, 2, 3. Okay. Let's just check here. Okay. So we have this one. 1, 2, 3. Okay, no, you are right. So this, this is only on E and F. Yeah, thank you. So this is only on E and F, not D. E and F only. So it's supposed to be 2, 1, 2. Okay, and the big one. Thank you. Let's fix that one, because I honestly don't know where's the eraser of this thing. So this one is not supposed to be here. Are you guys with me?
Sir, the eraser is next to that picture import symbol.
Picture import symbol.
They're on the
This
right.
side?
Yeah.
Oh, yes. Thank you.
Pleasure.
Okay. Our eraser is working. Yeah, perfect. So actually we can even erase this one from here, because this is where the problem started. Okay. So now we broke this. We changed the sign. We have 2 marks. We still have this, and then we still have this. So remember, double complement, it results in just A, right? So here we're going to have A, B, C, B, C, not. We're going to throw away this double complements. They're just going to cancel each other, right? Here we still have the AND. So here we have this big line now. We need to break it. We need to break the line and change the sign. Change the sign. Okay. So what are we gonna do? So we're gonna have D. Let me write them down first. We're gonna have D E plus F, right? Then the F is complemented, right? Then there's this big one that complements E and F. Then this one has to be split in half now. So it's gonna take here and here. Then we're going to change the sign in between. So like this, it was multiplication, right? So we're just gonna change it into an O. Instead of an and, it's gonna be an O. Okay, perfect. So now we are here. A plus B, C. We'll change that now. Dot D plus. So now remember, double complements, it cancels each other, right? E plus F. Okay, let's just put our complements now. We know F is still complemented. We know C is complemented. We know D is now complemented. D is complemented. So this and this, they cancel each other, right? So now this will be our answer here. So check properly here. So the only thing that you do here is you just break the line and change the sign. And then with Demorgan's theorem, and then you just remove the double complements. That's it. Break the line, change the sign. You break into two, change the sign. Then you remove the two complements. Let's see if this can be simplified any further. I don't think so. Okay, let's see, what did we get? A, where is that? Where is it? It's here. Okay, let's see. E plus F not. This two went. We had F, we had D naught plus E F. Yeah. No, we can't simplify any further. Let me go back to it. So this is basically our final answer. So because this is multiplication, you can just group this into brackets. That's it. So this is our final answer. Yeah, are you guys with me? Any questions? We did Bolean algebra and Demorgan's theorem for today. Any questions? Okay, let me just open this one thing that I like here. Okay, great stuff. So we did this, we'll touch on this. I just wanted to start with that difficult topic. Then we looked at this, right? We looked at this. We did this in the past. So today we looked at this. We did this in the past. We looked at the kernel maps in the past, expanded forms, logic circuits, right?
Do you mind doing the maps again, please?
Yes. Okay, we'll do them. Yes.
Thank you.
Yeah, yes, I just want us to set the schedule for the next session. What are we going to look at? Then this as well, we did this sigma notation. Here are the laws, right? A plus A is A double double, it's A. So here are the laws, we did this. Now, your theory again, you see, truth table of a positive hash triggered SR flip-flop. They might ask for the latch as well, the latch, and they have asked for the D flip-flop, right? SR flip-flop, is it the RS or the SR latch? I can't remember. Then the D flip-flop, right? Google those things, just get the truth tables ready and then know the truth table. So from the truth table, you can be able to see how they work. But I will also upload some notes on this and cover it. Okay, so now our time is up. So let's choose what are we going to focus on next. I'm thinking, why don't you guys try this November? This question paper, I always recommend it because it has everything. It really has everything that you need to know. So I can post it, then you guys can try it. Then we will look at the Carnot maps, and the Carnot maps, they like asking it like this. That's why I like it here. They will ask you to put WX in the columns and YZ in the rows, right? And you see how many marks is this. So we can look at the Carnot maps, right? And then, oh, do you guys have time? I have 15 minutes. I can stop at 8. What do you guys think?
I think you can give us time to do the test, and then on the next session we can go through the test.
All right. Yes, perfect. Okay, yes, please, guys, do the test, and the next session we'll go
Is the
through.
test on the MyUnisa site, or does it still need to be uploaded?
I will upload it now. I will
Okay.
make sure that
Thank you
it's
so much.
uploaded now. Yeah. All right,
Also,
guys. No.
please can the next session not be too far away because the exams are starting really soon and
Yes,
everything is packed.
the next session is on the 26th.
Okay,
Tuesday.
fine.
Yeah.
The same time.
Yes, same time, same link, everything the same. Yeah.
Okay.
Okay. I will just make sure that I upload this now so that you guys can start working on it. And please, if you have questions, guys, no one is sending questions now, but you will see 2 days before the exam. If you have questions now, post those questions. I know you can't post, email me the questions then.
So I did email you something. I don't know if you saw it yet, because I'm struggling with that Sigma notation stuff.
Oh, and that's the easiest thing.
No, it's
But
when they
I'll show
say
you.
write the simplified form of the expression as a sum of product. I'm struggling with that.
Simplified. Okay, not a problem. Let me just show you quickly. So sigma, it comes from this stupid sign, right? Right? Sigma, it's a sum of main terms, right? So this is when you write it in sigma notation, main terms. So now I want you guys to do this always. A, B, C, D. A, B, C, D. We're gonna do a quick one. A, B, C, D. It will always be like this. It never changes. A, B, C, D. Okay, so this is what you do. Let's complement C in this one. Let's not complement anything. Let's complement this one. Let's complement this one. Let's complement A, right? So this is already a sum of product, right? What does sum of product mean? What's a product? A product is a result of a multiplication, right? Product is a result of a multiplication. So 2, 7, I wanted to type 2, but it's 7. 7 multiplied by 2, right? For it to be 14, this is this is a product, right? This is a product, 7 multiplied by 2. So now what are they doing? They are taking A, B, C, D. This is multiplication. This is 7 multiplied by 2, multiplied by 2, multiplied by 7, plus 7 multiplied by 2 multiplied by 7 multiplied by 1. Yeah, it's basically, so this is a product, this is a product, and then they are adding the products. So that's why it's called sum of products, SOP. So what does it mean for sum of product? It means that for this combination, the output is high. It's a 1 here, right? The light is on. Door number 1 is on, door number 2 is on, this one is off, this one is on. The light must be on to warn you that your doors are open or something. Okay, so now this is what you do. So you first, I want you to convert it to binary. We need to cheat where we can cheat, right? But you get full marks for this method. 1, 1, 0, 1. 1, 1, 1, 1. So what did I do? Everything that's high, if it's complemented, it's low. It means it's off. Everything that's high, it's a 1, represented by a binary 1. Everything that's low, represented by a binary 0, right? So this is high, 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 high. That's why you see 1, 1, 1, 1, right? Then from there, this will be 1, 0, 1, 0, right? Wacht net 'n bietjie. No. This is B is 0, C is 0 as well, and D is a 1. So here, A is a 0, B is a 1, C is a 1, D is a 1. Yeah, something like this. So now, from here, you just need to convert this into binary. Into decimal, from binary to decimal. So how do we do that? Simple. 1, 2, 4, 8. 1. It's basically 1, 2, 4, 8. 1, 2, 4, 8, 8, 4, 2, 1. Right? 1, 2, 4, 8. So you convert this into binary. We know this is. Let me do it like this. This is, for example, 2 to the power 0. I'm not gonna follow the whole course. The whole method here is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Okay, let's pretend that is a 2, 2 to the power 3. So this will be 1, this will be 2, this will be 4, and this will be 8, right? So now when you take your 1, 0, 1, 1, we know this is present, this bit is present, which is a 1, plus, well, so you basically just convert 1 plus this 0, let's not write this 0, okay, but 0 plus, this will be a 4, this 4 should be present, 4 plus this 8 should be present, right? So now everything together here is a 13, right? 13. Now you have 13. 13, okay. Let's put a comma. I like to put a comma. So this 1, 1, 1, 1. This is 1, 2, 4, 8. 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. So this is basically 15. Let's just put a plus so that you don't get confused. Then this one, 1, 2, 4, 8. This is a 9. 1 plus 8. 1, 2, 4, 8. This is a 9. I put the 9. Right? This one is a 7. 1, 2, 4. 1 plus 2 is 3 plus 4 is 7. 7. So your answer in sigma notation, the sum of main terms, and now they don't even mind if you don't sort it, but I prefer to sort it. It's 7, 9, 13, 15. So the most important thing, this may have a binary representation. Then from binary, convert this into decimal. That's it. Are you guys with me?
Okay, so now how do you convert? You have the midterm 7, 9, 13, and 15 now. How do you convert it back to A, B, C, D? Because in my assignment, I got that question wrong. But I did it, how can I say it? I did the exact opposite of what you just did to get the A, B, C, D, and all those things. So
Okay.
I was just wondering, how do you convert it now back?
Okay. If you need to convert it back, it's pretty much simple. Okay. What you can do is it's a 7, this is a 7, and now you need to have somewhere where they give you the number of variables, right? So now let's say the number of variables it should be A, B, C, D. So they will have that. Normally they will say X, right? X, and then they'll put a small bracket here. And then here they will have A, B, C, D. Then you know how many variables are you working with, right? So it's normally 4, A, B, C, D. Are you guys with me? Then you know it's 4, right? So now what you do, if you have this, you convert this back into binary. So this is a 7 with 4 bits. So this will be 1, 1, 1, 0, right? 9, it will be 1, 0, 0, 1, right? 13, okay, let me jump to 15 first while I think about 15. Now while I think about 13. Okay, so for 13 we need a 8, then we need a 4, which is a 12. This 2 we make it a 0, then the 1 we make it a 1. Then from this we know this is A, B, C, D, A, B, C, D, A, B, C, D. So this will be A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D. Okay. So now, we know this is low. We know this is high. B, C must be low. Then here, 1101. The low one is a C. Then here everything is high. So this, where's the 7? Which one is the 7? Here's the 7. So this, we should get not A, B, C, D, not A, B, C, D, right? Not A, B, C, D, here it is. We should get A, B not, C not, D. A, B not, C not, D. Here it is A, B not, C not, D. We should get A, B, C not, D. A, B, C not, D. So here is. Then we should get A, B, C, D, A, B, C, D, A, B, C, D. Here it is. Are you with me?
Yes, thank you, sir.
All right. Okay, guys, please try to do it. I think I don't think my first email is working. Maybe you sent me an email on that one, hey? My first email has been blocked because I didn't register. So let me send you. Let me post my new email. It's not a new email address.
Yes,
I've
because I
been
sent
trying
it to the email that is on your Teams account, linked with your Teams profile.
Oh, okay. Oh, but why didn't I get it? And what's your name or your email address? Because you
My
should know
email
this guy.
address is the student one, so it's a whole number. I can quickly type it for you.
Okay, but it will have UNISA, right?
Yes, it has Unisa in it.
I didn't get it. I didn't get. Maybe in my junk. So I'm using the work Dirk listen No, I didn't get it. Get it. Please just use larrybiakas@gmail.com if you don't mind. This Teams is basically for work, but yeah, I'm just using it for these lessons because at least I get to store the recordings on our shared drive, and then I can upload them on YouTube for everyone to access.
Okay, thank you, sir. Appreciate it.
Okay, you're welcome. I'll send you an email as well from my Gmail, then you can respond to that one.
Okay, thank you very much.
All right. Okay, guys, have a
Yeah.
nice one. We'll meet
Same to
again
you.
next week. All right, cheers.
Hello,
Cheers, bye.
Mr. Larry, can you load the recording in this chat, please? I wanna go through it after the session. I know you said you're gonna load it on the notes.
So you want me to?
After the session, just to load the recording of this session in the chat of this discussion.
Okay, no worries. I will do that.
Thanks.
Okay, thank you. Cheers, guys. Bye. Stop the recording.